Hello everyone. In this lesson, we will learn about the construction of subgrade drainage projects. Let's start with a case study. In 2012, a traffic accident occurred in Tonggu County, Jiangxi Province, caused by water accumulation on the road surface due to leakage from tap water, creating potholes. The case was tried by the People's Court of the county, and the Tonggu Highway Management Bureau was ultimately held responsible for compensation and joint liability. Through this case, we learn to respect the rule of law and protect our legal rights through legal means in the event of personal injury. Common road water damage includes highway surface damage, side slope collapse, subgrade collapse, etc. To prevent water flow from affecting highway safety, drainage facilities are set up to divert the water. Drainage facilities include surface and underground drainage systems for subgrades. Next, let's learn about surface drainage facilities for subgrades. First, let's start with side ditches. Their cross-sectional forms include trapezoidal, rectangular, triangular, and streamlined shapes, among which the trapezoidal cross-section is most widely used, characterized by large drainage cross-sections, and its inner side slope is between 1:1 to 1:1.5. As we can see in these two diagrams, the depth H and width B are typically between 0.4 to 0.6 meters, and the outer side slope gradient is the same as the excavation slope gradient. The rectangular cross-section is characterized by occupying less land and being convenient for construction. Its inner side slope is vertical or slightly inclined. Its depth H and width B are usually between 0.4 to 0.6 meters, and the outer slope gradient is the same as the excavation side slope gradient. The triangular cross-section is convenient for mechanical construction, and the inner side slope should be between 1:2 to 1:3. Its depth H, width B, and outer slope gradient requirements are the same as above. The streamlined cross-section is aesthetically pleasing and harmonious with the environment, often with a radius of curvature of 0.3 meters at the streamlined arc. Side ditches are generally placed on the outside of the road shoulder in cutting sections or on the outside of the lower slopes of embankments. Their longitudinal slope should be consistent with the road's longitudinal slope and should not be less than 0.3%. In difficult situations, it can be reduced to 0.1%. To prevent water from overflowing or eroding the side ditches, an outlet should be set every 300 to 500 meters for unidirectional drainage. Next, we will learn about catchwater drains. First, let's look at the catchwater drains in cutting areas. As shown in position 1 of the left diagram, its function is to ensure that the excavation side slopes are not eroded by water flow. Fill catchwater drains, as shown in position 2 of the left diagram. They are used to prevent the embankment's foot from being eroded by water flow. The cross-section and size of catchwater drains should be determined based on the location, drainage volume, and side slope conditions, usually adopting a trapezoidal cross-section as shown in the diagrams. The left diagram shows a catchwater drain set up on a clayey side slope, and the right diagram shows one on a rocky slope. From the diagrams above, we know that catchwater drains are generally placed on the slopes of cutting sections or on the upper side of steep embankment side slopes, perpendicular to the direction of slope water flow or essentially parallel to the contour lines. The need for one or multiple channels is determined based on the amount of rainfall. Their longitudinal slope should not be less than 0.3%, and the length should be determined based on the principle that the collected water neither causes excessive erosion nor accumulates. The gradients of both sides of the channel depends on the geotechnical conditions, generally between 1:1 to 1:1.5. The width B of the bottom of the channel should be no less than 0.5 meters, and the depth H should be determined based on the designed flow rate, also not being less than 0.5 meters. In this lesson, we have learned about side ditches and catchwater drains. I believe everyone has gained some insights, and I hope this lesson has answered some of your questions about side ditches and intercepting channels, laying a foundation for further in-depth study. Thank you.